Hello, everybody. So, welcome to the episode. I'm here with Steven Pemberton. Steven is someone I'm very happy to have on the episode. We met at my first Janus Boy conference in Denmark a little while ago, and immediately hit it off as old dyed-in-the-wool XML and structured content folks. Steven, do you want to say hi and introduce yourself a little bit?
Hello, I'm Steven Pemberton. I'm ethnically English, but judicially Dutch. I live in Amsterdam, the Netherlands. I'm a researcher at the CWI, which is the Dutch National Research Institute for Mathematics and Computer Science. I went to university. My tutor in England was Dick Grimsdale, who built the first transistorized computer. His tutor in itself was Alan Turing, which makes me a grand tutee of Alan Turing. And after university, quite coincidentally, I went and worked in Turing's old department, working on the fifth computer in the line of computers that Turing himself worked on before he died. He worked on numbers 1, 2, and 3. Then I was a university lecturer for a while, and then I came to Amsterdam as a researcher, where I co-designed the programming language that Python's based on. I was the first user of the open internet in Europe when the CWI set up the first open internet node in Europe in 1988. And I went on to get involved with the web right from the start, which means that I then co-designed a lot of web technologies like HTML, CSS, Xforms, RDFA, and a number of others. And I'm still working on a couple of internet-based things, and I'm very happy to be here.
Okay, fantastic. Yeah, it just warms my heart hearing your bio. I don't talk too much of my older background in the beginning of my career on the podcast, but I was born into the world of structured content, XML, RDF, straight out of university. So I was just a youngling and kind of discovered the web through that lens, through what we now call a semantic structured perspective. And
right.
Only kind of halfway through my early career did I discover that people were ever doing it another way. Much to my shock and dismay and confusion, I found out that people were just throwing their content into these big buckets called Word documents and web pages, and then chucking them into even bigger buckets, which they called content management systems. And obviously, we're suffering many problems, which we continue to suffer today. I think one of the things that we've been talking about since the very beginning is this simple concept, and listeners of the podcast, many of you will be familiar with it, but I've got Steven Pemberton here, so I'm going to bring it up, which is we're still talking about the fundamental issue of separation of format and content, the way it looks from what it actually is. Are you still running across this when you're talking to people, Steven?
Well, absolutely. I mean, separation of concerns in general is a concept that doesn't seem to have sunk into a lot of heads. So, I mean, not only content and presentation, which of course is absolutely essential, but also content and data, for instance. You can separate those out. So there are a number of things that are beneficial to separate, because then you have more freedom to deploy over different sorts of media. But yeah, there's still a lot of work to be done.
So tell me about that content from data. That's an interesting one, because the data content, and if I want to get, I don't know if I want to open this can of worms, or when we get into data versus content versus information versus knowledge, like there's, especially in the authors circle, we're having bitter fights about these terms all the time. So when you say separating content from data, what are you referring to? What's an example of where I would separate?
Well, so an example, a simple example that I use is, imagine you're getting a contract from, let's say, a book publisher. Now, there's one level of separation content from presentation, in the sense that there's a whole bunch of text, and whether that's in one font or another, or displayed in color or whatever, that's all presentation issue, because what you're interested in is the actual content of the text. But there's another way that the publisher, for instance, would look at it as, oh, that's a standard contract, but there are 3 pieces of data here that change: the person's name, the royalty percentage, and the title of the book.
Thank you. Got it. Go on. Please go on. Please go on.
Yeah. And so for the publisher, the presentation includes all that text that we think of as content, because the only content for the publisher are those 3 bits of data. So there are different levels you can look at it, going from the data down to what gets presented on the screen.
Thank you. Thank you. So that's a very interesting way of putting it. I'm going to talk to that through the lens that I've been discussing it recently, because we're discussing content models all the time. And what I have found, we're looking at a lot of the new CMS systems, the headless CMS systems that are coming onto the market. We're doing content models for them. Headless CMS is a very popular topic with our listeners and in the world. The new breed of headless CMS, for better or for worse, seems to be finally bringing the idea of separation of content from presentation to the wider world. I'm not going to say it's mainstream yet,
right,
but it's as we've been talking about this since you were half my age. So we've been talking about this for better part of half a lifetime, and now we're starting to get some more mainstream success of just the idea of separating out content from presentation. As you said, tons of work to do. But what you just talked about is, when we talk in content modeling terms, the idea that not all content types are equal, and that there has to be a sort of perspective on the hierarchy, sort of what I call the concentric circles of your content. So if you have, for example, you just gave a perfect example, like a contract, where we've got certain clauses which are standard clauses, which we're going to reuse again and again and again. They may have, we call them clauses. We might also have disclaimers, jurisdiction. I don't know. I'm making up the content model for a contract as we speak. We do a lot of pharma work. So you're talking about studies. Studies have results. Results have different types. You have safety results and efficacy results. You have data, what they call endpoints, outcomes of the study that were planned when you went into the study, and then other things you happen to discover during the study, so unplanned endpoints. And you treat different companies have slightly different words for these things, but you have these recurring structures. Within those, then you may have smaller data points or smaller variable content, if you will, that changes. So a product name, or a particular molecule, or, as you said, the author name on a contract for a book. These are tiny little things which deserve to be and do need to be managed, but they are not well handled in some of these new systems that we're seeing. It becomes very difficult to properly say, okay, well, this is our broad structure of what a contract looks like. That doesn't change very often. Then we have, within the clauses, we might have a bit more play there. Some clauses come in and out, and then we have these tiny little pieces you've given the term data level, which change all the time, and maybe every time. And this thinking of the hierarchy of not only am I structuring content, but I have to have levels to separate out frequently changing, frequently personalized by, or changed or adapted by region or context, other kind. Where are your levels?
Where are my levels?
Or
no.
Just in the theory, when you're working this out, where are one's levels? That's fantastic that you brought this up. Do you have any ways that you kind of help people wrap their head around that?
Well, I mean, one of the technologies that I'm currently co-designing is Xforms, which is based on a lot of abstractions. So the idea of abstraction is that you try and get to the essence of the thing. So, for instance, although the name suggests it's about forms, it's not. It's a programming language. But what we do is we have controls which represent what they do, but not how they look. So, for instance, if you think of a drop-down menu where you select one thing, or a pop-up, or radio buttons, they all do the same thing, namely select one from a list of things, and you present them in different ways. And so we just have a control that says this is a thing that selects one thing from a number of things and has a number of possible presentations, but you represent it in the code in just one way. There's no visible in the code. There's no visible difference between the different representations. But then where it gets that data from is completely separated out. So like a style sheet, we also have, as it were, data sheets, which we call instances, which contain the bits of information. So that you have a complete separation of the data and the presentation and the control, which in fact has turned out makes it much easier to program in the first place, but also to be able to move through different media, different presentation forms.
Yeah, so I think that so people can think about that kind of thing where if you're defining user options. I like that drop down example. So
yeah,
that a drop down kind of radio boxes, tick boxes. There's lots of ways you could represent. Here are some options how to choose from them. And we're moving to a world where we want to define these in truly channel agnostic ways. As we're seeing voice to text interfaces, using language models to be the interface where we speak to the content, and users will be presented options. This ability to have this logic defined in a way where you understand, you may show this to people in radically different ways. Literally, like different, what we call different modalities. This is
no, absolutely, yes.
Yeah, no, I know you know. But this is a term that I dug it out because we published our book 11 years ago, and now it's coming into the dialogue again because of Google. Google is releasing their models and going, see, ours is multimodal, whereas theirs is just text.
Well, in fact, that one of the implementers of Xforms demonstrated this by showing the same program running on a screen with typed input, and then on a voice browser. Same program, but in two different modalities. One where you're interacting using your voice, and the other way you're interacting using a keyboard. And we really have to head towards that sort of specification where you don't specify it once for one sort of modality and another way for another modality, because the abstractions are exactly the same. You want to choose one from a list, and it's the implementation that should then, decide how it's going to present that to the user, and not that you have to specify that differently for every different modality.
Fantastic. So we've been kind of saying this message for the content for years. And those who took the message, saying, okay, if you properly structure your content and separate it from the fact that it's web format or app format or print format, then you will be so much more future-proofed against, maybe you're not using those channels today, but when the market or management shows up and says, we want an app, or we want a chatbot, or we want a Huzumaflitz, whatever is about to come out, they don't want to wait 3 years for you to rework all of your content.
Oh, sure, absolutely.
And so what you're saying is the same thing now for the functionality, the interaction design.
Absolutely. But I have bad news for you in a way, because you and I are thinking.
I'm used to that.
You and I are thinking sort of about the future, and we have a vision about how it could be, but in fact we're dealing with a generation that's grown up with editing documents in Word, where everything is presentation oriented, and that a lot of people haven't got into the idea of saying, oh, this thing is a heading, but sort of select it, make a bigger font, turn it into bold, and that's their heading. And they're thinking the whole time in presentation concepts and not in the underlying abstraction. Now, the bad news is that similar things happened with the introduction of the book. And I like to compare the introduction of the web with the introduction of book, because many similar things happened. That with the introduction of the book, books in the first 50 years of the book looked exactly like manuscripts. They used handwriting fonts. They didn't have page numbers. They didn't have tables of indexes or contents. It was exactly like a manuscript. And it took 50 years before people started having the bright idea of page numbers and readable fonts and all that sort of stuff. Now, why was that?
And then only once you have page numbers can you have such a thing as an index.
Exactly. So why did it take 50 years? And the answer is because they were in an environment where people were used to manuscripts, and so they were providing for them. And so they had to wait for that first generation to die out before they could start producing books for the new generation who didn't have the expectation of manuscripts. And unfortunately, we are still living in an environment that still thinks in terms of bits of paper. I mean, we even say web pages as an example, and they're not pages at all. And that in order to achieve the things that we think should be achieved, we're going to have to wait. I mean, it's hard to educate the whole of society in one big go. So I fear that that the first generation has got to die out before we can really achieve the things that we're talking about. But that there are such huge advantages to the things we're talking about that the sooner the better, because it reduces costs 100-fold. I mean, I have examples of people producing systems with Xforms that in 100th of the cost of the equivalent system using old technologies.
Well, yeah, if you think about it. So when we talked about just structuring your content properly so that it's can be rendered out, can be delivered out in 3 different formats, and the little variables like we were talking about earlier. So this is the British version, with British language and British metric units and etc. The British data values, and also in all the other English countries, and then we're going to translate that, but we're all going to share one source. And then we've got all these different products, which are 90% the same, except for these 10% little differences. And you can configure those products depending on your industry and application. So you've got, from one set of source files, you've got hundreds of actual variants of the possible output. And that's just the content. And so now you're adding the layer of the interaction and the functionality of writing the interfaces, so that when the boss says I want that on an app, or I want that in a voice interface, you don't have to go hire a team to recode the whole thing. So
it's interesting what you say there, because you're talking in hundreds of different variants, but in fact the number of variables that create those hundreds of variants are actually rather small. There are only 3 or 4 things that you mentioned. And so purely coincidentally, I'm at the moment designing, actually only for myself, but a recipe app that reflects all these things, like names of ingredients, but metric or imperial units and so on, but also how many people you want to cook for. And so you can change those things, and you get a version of the recipe that matches those. But the number of variables are very small, so that you only have to change 2 or 3 things, and then you get one of the hundreds of options out. That's the joy of such a thing, that you don't have to translate your content into 100 different versions. You just have 1 or maybe 2 versions, and you just leave the holes for calculations for what the reader is going to expect at that spot.
I actually had an old slide which I need to pull out more often, which was called multiplicity, and it had exactly what you're saying. So it had kind of like layers. So it said like 5 deliverables, documents for a better word. So collections of information. So we've got 5 sources times 5 regions times 5 industries times 5 4, et cetera, et cetera, et cetera. And I think I went like four or five layers. It wasn't always 5, so sometimes 4, sometimes 7. But these,
Yep.
as you say, small numbers, you can count them on your fingers. And
Yep.
then and you keep multiplying out. On the right, you have something like 2,000
Yeah.
different outputs.
Exactly.
Which an organization has two options today. Either they don't deliver them, even though there is a market need or a user desire, or they deliver them at excruciating cost and time. It's one or the other.
Yeah. So I mean, that's one of the powers of X forms, is that these are variables in your data that you change, and then all the rest are just constraints and calculations based on those, and your content then comes out to match what you've specified. So that's one of the reasons why you can cut the cost of production by such a huge amount, because you're not having to worry about all those differences.
So we mentioned X forms kind of on the fly several times. So let's back up. And
right.
So I've heard of a website, and I've heard of an app. So, and I understand, Microsoft Word. Introduce X forms to me from the beginning. Who uses it? Who uses it? When would I ask someone to use it? Would I use it myself? What?
Right. So let me back right up.
Yeah.
So the first programming languages were designed in the 50s: COBOL, Fortran, Algol, Lisp, the big four. And in the 50s, computers were immensely expensive, millions. And a programmer was very, very cheap, sometimes almost free in comparison. And so
I think you said when I met you that the company would give you some programmers if you bought a system.
Well, not bought, but
not quite.
The computers were so expensive that most didn't buy them; they leased them. And if you leased a computer, you got a couple of programmers in the deal. And the reason that was good was because all computers were different. So it was great to have somebody in-house already who knew the operating code, the operating system, and could teach others and start writing programs for you.
In a world completely before standards.
Exactly. And so the economic relationship between computer and programmer was that the computer was hugely expensive and the program was essentially free. And so therefore it didn't matter if programming took a long time, as long as the computer wasn't put to too much trouble. Over the years, of course, the cost of computers has plummeted and the price of programmers has risen. So that in about the 80s, they actually crossed, but without any sort of fanfare. So that now computers are almost free and programmers are really expensive. But we're still programming in programming languages that are direct descendants of those four that I mentioned, that you're still telling the computer step by step how to perform, because you're assuming that you're still assuming the computer's expensive and the programmer is cheap, and it's not that way around. So much of my research has been based on trying to fix that relationship, trying to design programming languages that don't make that assumption, and therefore try to save programming time and not computer time, so that you let the computer do more of the work for you. So that's one of the things behind Xforms. Now, Xforms is, rather than a procedural programming language, is a declarative programming language. Now, the example I use of the difference between those two things is, at school you learn how to add, multiply, divide, and subtract procedurally. So you actually learn how to do it. But at a given point, you're told what a square root is, that a square root of a number is a number that if you multiply it by itself gives you the original number back. You learn that concept, you understand what it is, you could recognize one, but nobody comes from school with the ability to calculate a square root. Nobody knows how to do it. So that's a declarative definition of square root. You know what it is, you've said what you want, but you haven't said how to do it. So we're designing a programming language where you much more describe the solution space rather than the route to get to the solution. It's like you give a picture of the cake that you want rather than the recipe to bake it. So it's much, much shorter. It's much easier to do. It uses a little more computing power, but one big example said that it was only about 50% more computing power, but this was a huge project that they normally did with 30 people in 5 years, and they managed to do in 1 year with 10 people. So they've gone down from 150 person years to 10 person years. So that was a cost that they were, the extra runtime wasn't a real problem for them because they'd saved so much money in the interim. So
I just want to interrupt there to remind everyone in the audience, for all these times that they've gone to technical departments or teams and said, I want an X, or I want to change this functionality, or I want to change this web page, etc., and had to wait 8 months for what from the outside seems to be trivial changes. Like, why is it taking you so long?
Right.
And so I think this getting to the root of building things so that they are maintainable faster, they are adaptable faster, and as you said, like 100 times faster. That's the kind of change that we need.
Yeah, exactly. And so, I mean, I personally believe that once the managers get wind of this fact that you can produce the same stuff in with the hundredth of the resources, I think that in the end, programming will go that way, just because there's so much advantage to it. And I have many examples of such advantages. I mean, there was an insurance company that wanted an app, and so the manager said to the programmers, I want you to work out for me what resources you need to build this app, and said it also to the Xforms person. And 2 days later they came back, and the programming guy said, well, I need another 30 days to work out what resources I need for the app. And the Xforms guy had written the app already in those 2 days single-handedly. So it's 2 orders of magnitude better. So the advantages just are fantastic.
Yeah, I'm so the excitement of adding that on top of structuring content, so that it's just it's dizzying. I'm sure that there's going to be several people who are listening to this podcast who are struggling to wrap their heads around doing things hundreds of times faster.
Right.
I wasn't going to raise this because we don't see fully eye to eye on this topic, but you kind of dragged me into it kicking and screaming, because you're reminding me so much about the topic of how we talk to and how we discuss artificial intelligences.
Right.
In the sense, I'll say what I think the parallel is, that when I'm training people, or I'm giving people methods for how to use an artificial intelligence, we talk about turning the problem around. Rather than figuring out exactly what you want this application to do, you are trying to figure out the logic of what the result you want. How do you want the result to be? What is it that you're after? And rather than micromanaging, you're explaining what the solution looks like. 2 things. Do you see any connection between these two? And is my initial gut reaction of, oh, well, if I could explain with my words to an artificial intelligence, then it could build me an Xforms application. Could that, would that allow even me as so many of the people on this listening to this podcast will not be programmers themselves.
Right.
Or I do not want to become programmers, do not want to get their hands dirty. But writing out some clear instructions of what they're looking for might be. So do you envision a world where, and I do, what do you think about this vision of a world where the average business user can actually be able to explain their desires, and actual applications will come out the other end?
So my fundamental point of view is that if it works, you should do it, right? That's the essence of everything. And so saying to AI what you want and then getting it is the same as saying that to a programmer. And you've just replaced the programmer with a program that does the same thing. So, if that floats your boat, then by all means that's great. My as you know, having been to my talk, my problems with AI is that firstly, there's no I in there yet. That it's machine learning, but it's not artificial intelligence. So that you can't trust it. And as an example, I asked a machine intelligence, a machine learning program, artificial intelligence, to write a bio for me, and it was okay, but I couldn't accept it as it was because there were errors. So I had to fix it up, and that's the same with programming. That I wouldn't trust. Well, to be fair, I wouldn't trust a program written by anybody because we programmers are used to the idea of debugging, and so that means you're always going to get buggy programs, as we are seeing, for instance, in the UK at the moment with the post office scandal. I don't know if you followed that, but
I saw a quick little thing about it. Basically, the post office was just using buggy software for ages, and actually the citizens, the taxpayers, were getting the stick.
But yeah, the people at the post, the people running the post offices, they were getting blamed for the mistakes in the software, that money was disappearing because of bugs in the code. But but anyway, we're getting away from the from the subject. But
applications have bugs.
Yeah, applications have bugs.
Everybody in the modern world knows that.
That's right, and they will from AI as well, because there's no intelligence there. You've described something; it's going to copy code from elsewhere because that's all that machine learning does. And so you won't be able to trust it any more than what you get from a programmer. But as I say, if that does it for you, then do it. But my critique over AI is more about that it's not intelligent, and that you can't yet trust it.
So I think that we can overlap, and we've only got we're coming up kind of to the end of the time, and I don't want to launch into that debate. But I think where we do see the eye to eye very much is when we come to this reliability word. And I'm cooking an article in my head about this. I haven't made it public yet. But where you can use what we're calling AI today is in the places where you can tolerate a lack of reproducibility and consistency. So the point is, we've been thinking about computers as infallible calculating machines. No matter how many times you ask the computer to for a 10-digit number factorial, or to multiply to 50-digit numbers together, every time, and every computer will always get that right. And the idea, and then we just scale that idea up. Okay, so I need these files moved from here to here, and every single time I want all the files from here moved from here to here. And if it doesn't, we call that a bug. Now we've introduced a type of computer application, and I also kind of put big air quotes on that, which doesn't do that. It's there's a roll of a dice there. Sometimes it'll just do something, it'll come up with some sort of weird variation of that because it dreamed it up, or etc. But as you just said, kind of like we do. So rather than trying to employ these things in places where you need computer reliability, as we've come to be accustomed to it in the past 40 years, you need to employ these things in places where a little bit of a roll in the dice doesn't disrupt your business process. Sometimes that I've been thinking about it like creatives. I don't hire my accountant to decorate my house, and I don't hire my interior designer to do my accounting for me, because they're different skill sets. I need different things out of that type of resource. So this is kind of where I do agree that we shouldn't think about them as an artificial intelligence if what you mean by that is the benefits of a computer and the benefits of a human. They do not have that. They absolutely do not have something that you can trust, like a computer application, but with this sort of kooky eccentricity, which so you need to think about, where can I use a little bit of kooky eccentricity in my business? Where might that be useful? And don't expect the best of both worlds.
Right. Which then raises the point, to what extent do you want to have an AI do your programming? but it might be just as bad or just as good as a human, but don't expect it to be perfect by any means. You're still going to have to check it out and test it. And like my biography that it wrote, it just got things wrong. Didn't get things wrong. It made things up that just weren't true.
Oh, so my just as long as we're here on this, I spent the holidays trying to get a chat GPT that would take the transcript of a video, pull out some salient quotes, and put the times next to them. Incapable. It just could not do it. It would make up times. It would put in phrases that weren't quite there. It would start to do the first half and it would kind of get bored. It really does feel like working with an intern who just arrived from maybe from college, but also maybe a high school diploma kind of intern.
Right.
It really feels that same kind of way.
Yeah.
Okay.
Yeah.
So there are, like, to sum up, so we've got lots of great things on the horizon. You can check out where can people learn more about Xforms and
well, if you just go to my homepage, then there's that's just a collection of all the things that I do, but including resources about Xforms that where you can learn more.
Do you have any kind of like a best introductory webinar or something that people can put into?
Yeah. If you go if you go to my homepage and select the Xforms introduction to Xforms, then you'll find tutorials. You'll find some videos. You'll find a whole bunch of quick references, a whole bunch of resources.
Great. Okay, so I recommend people check that out. Maybe not for your own needs, but just to understand the comparison.
What it's about.
Yeah, what it's about, and maybe raise that in your organization, see if anybody else has looked into it. Maybe you can be an innovator. As always with everything that I'm associated with, probably not necessarily something that you'll implement tomorrow, but getting you ready for the next 10 to 20 years.
I have to warn you that a lot of programmers don't like the idea that they have to rethink how they program.
Yeah.
And so if you ask a programmer to compare, they'll often say, oh, no, this is no good, or this is not the sort of stuff that we do.
Too different.
And it's true. Yeah, it's too different. But I should also point out that just this week I found out that the FDA, the drugs organization in the United States, is using Xforms amongst others. So
you mentioned also something, the UK ambulance service, was it?
The National Health Service, yes. So this was a project a disastrously expensive project that went completely wrong, and then one guy who worked on that project went away and rewrote it in 3 years alone using Xforms, and now it's running in the National Health Service hospitals, and is being rolled out over in Ukraine at the moment. So it's also good to know that it's being put to good use as well.
Yes, and the Ukrainians know their technology.
Yep.
Okay, so thank you so much. It's a pleasure and an honor, Steven, to have you on the show.
Great to be here.
Thank you for joining us, and everyone, let us know if you have any other follow-up questions for Steven. Oh, if people wanted to, are you a networker, LinkedIn kind of?
Yeah, you'll find me on LinkedIn. Yeah,
okay.
Absolutely. Yeah.
Okay, fantastic. Thank you so much, and we will see you all next time.
Fantastic.
Cheers. Thank you for listening. This has been the Omnichannel Podcast with your host, Naz Urbina, founder of Urbina Consulting. Let us know on LinkedIn or Twitter what you liked from this episode, what you think we missed, and who you would like us to interview next. Now that you've heard what we're passionate about, you can also check out urbinaconsulting.com to find out a little bit about what we do. Thank you so much, and see you next time.